Here we're looking at inverse functions of, and I'm going to pick several pre-calc topics and just go over them. Before we look at inverse functions, we need some background. First of all, what is a function? And that's the vertical line test. So if a vertical line only passes through one spot on the graph, then it's a function. And right there, it just crossed more than one spot. So this is not a function. And a function, it means that when you put in one x, you get one y. Put in one x, you get one y. It doesn't have to be unique, because you can find an x here to get one y and an x here to get one y, and it's the same as this x, but you're only getting one x, as opposed to if I pick an x here, I get several potential y values. Okay. The next background function is one-to-one, and that's the horizontal test. If a horizontal line only touches the graph at one spot, then it's one-to-one. Here it touches twice. Now this plot, or this graph, notice that it only touches one time. So why is that not a one-to-one function? Well, it's not a function to begin with, so it can't be a one-to-one function. And so the only one-to-one function is here. And really what that means, one-to-one, means one value of x, you get one value of y. And you can go backwards. If you pick a y, you get one x. That's one-to-one. So in this example, if you pick a y value, you get two x's. So this is not a one-to-one function. And so one-to-one functions have to pass the vertical test and the horizontal test. Another piece of background information is the composite function, f of g and g of f, and they're defined this way. Sometimes instead of writing this, you can just write it as a y. And the next one is domain and range. Domain's the input, range is the output. And so the domain is all possible values for a specific function, and the range is what you get out. So if f of x equal x squared, the domain is all real numbers. So every value that we pick, say 2, it's mapped to 4. If we pick 1/2, it's mapped to 1/4. If we pick -2, it's mapped to 4. Okay? And now this is a picture of a composite function. So you have a domain, and then you have a function that's mapped to a range. Now these are g of x values, but this could actually be a domain for another function called f, and then that's mapped to a range. So it's a composite function there. And this particular example is f of g of x. So next background information is plotting functions. And to plot a function, you set up a little table, you pick x values, they're kind of spread out, find their respective y, put dots where these are, and map it. Sixth background information is what's called a reflection about y equal x. So this is the y equal x line. And what that means is if this is x and you plug it into the function, you get the same value. So 10 is mapped to 10, 20 is mapped to 20, y equals x. So what's a reflection about y equal x? So if we put the dotted line at the y equal x and we have a function, then if we take this as the center axis and flip it around, so this piece gets mapped over there, which is what this function is. Notice that this, when it's rotated, gets mapped to there. This, when it's rotated, gets mapped to there. So the values here get mapped to here. Anyway, so that's called a reflection about y equal x. And it ends up, this is how you create inverse functions, but we'll be more specific on that. Another function here, this is the y equal x. So when you find the inverse or reflection about y equal x, notice that this little hump was on the top side here and it's on the bottom side here. That's on the bottom, then it goes to top, and so you can see that that's called a reflection about y equal x. So now let's get into functions. First of all, to find an inverse function, we can only deal with one-to-one functions. So that means it has to pass the horizontal and vertical line test. So if the composite of two functions equals x, then those are inverses of each other, and it has to equal both ways too. G of f of x has to equal x. So you put in x to this function, you get some number, and then you take f of that and you get the original number back. That's a definition of an inverse. A lot of times, instead of just calling it g of x, we call it f inverse of x. F inverse. And so f of f inverse is equal to x. That's by definition, has to be. If this doesn't hold, then it's not an inverse function. So so let's look at what it's doing here. So let's abstractly, if we have a domain, you mean what values we put into f and in the range. So we take a point here, it gets mapped to here, and then we have some function g that takes that point, which now this is the domain of g, or f of inverse, f inverse. It gets mapped to the exact same point that you started with. That's what an inverse mapping is. Whatever point we pick over here gets mapped to a point over here, and then its inverse maps it right back to the original value. And as I said earlier, graphically, inverses are reflections about this y equal x line. So this is the inverse of this function, and this function is the inverse of that function. And they don't have to be totally on one side of the y equal line. So here is f of x. Zoom. Now when we rotate this f about the y equal x, then it's mapped to this, and that's the inverse. So this line is the inverse to this line. And note that if the two graphs touch, it's always on the y equal x axis, or the line. Okay, so what that means, let's say we're given f of x, and we want to find the f inverse from the function that we're given. So using the function, we just switch x and y. We switch x for y and y for x, and then solve for y. So a quick example is this. If we have f of x equal to y, or x equal 5, so this is the same as y is equal to x minus 5. Then we put a y here and an x here, and this is what we get. And then we solve it for y. So take the 5 over, and we get y is equal to x plus 5. And that's what this is. So f inverse is x plus 5. Now, if we were to graph these, f of x is this function, and the f inverse is this function. And so graphically, if we were to flip this or reflect it about this line, those two would be right on top of each other. And that's how you find an inverse. So, but how do you show that it's an inverse? You have to plug in f of f inverse of x. So if this is f of x, x minus 5, and this is f inverse, so you put in x plus 5 in that x, and that's what this is, and then the minus 5 is here. And now we solve this, the 5's cancel and leaves x. So they are inverse functions of each other. Now a little more complicated one is here. So let's assume this is our function. Y is equal to this. Now how do we call that whole thing f of x? So how do we find f inverse? Well, for the x's we put y's, and for the y we put an x, which is what we did here. Now we start solving for y. So I multiply this to the other side to get that, and then I distribute the x in for this step. So 6x, 2yx, or 2xy. Now I'm going to subtract 6x and add, subtract 6x from both sides, subtract 8y from both sides, and then we get this. And this, we're going to factor out a y. That's what we do here. And then we divide both sides by this piece, and we get y is equal to this, which says f inverse is this function. Okay, so now the way that we could prove that is you take f inverse. So this whole thing and plug it in to this x and that x, and then solve it, and you'll get x back. But we're not going to do that to keep this video long. I mean, to keep it short. But I do have a trick question for you. Let's say we want to find f inverse of x squared. So if our function's f of x equal to x squared, how do you find the inverse? Remember, it's a trick question. So if we look at the graph of f of x, which is x squared, it's this parabola. So can we find an inverse function for that? And the answer is no. I mean, it passes the vertical test, so it is a function, but it's not one-to-one. So we can't find an inverse for it. So one thing that we can do is we restrict it only to the x equals 0 or greater. So if we cover up this piece here and only look at this, it passes the vertical test and it passes the horizontal line test. So let's find a inverse function to just this piece. Okay, so for x greater than or equal to 0, find the inverse function for f of x squared. So that means we're going to put a y here and then an x there, and that's what this is. So now to solve for y, we take the square root of both sides, and we get y is equal to square root of x. So the inverse function is the square root of x. So if we were to plot these, you know, this piece here is this piece, and the inverse function, square root of x, is this piece. And notice that they kind of flip, they cross, they touch two times, both at the y equal x line. But if we flip this like this one flips to that, and that one flips to this. Anyway, that's how you find inverse functions. Hope you enjoyed the video. Please like it, subscribe so you don't miss the next one.